And can you let me know when you've given them the link as well?
Yeah, that's fine. Is it best to share it out in the beginning?
Yeah, because they're gonna need to follow along.
Okay, yeah, I'll post it just as you start then.
Okay.
Great.
All right. Well, good morning and welcome to Microsoft Reactor. We're going to have some fun today, introducing you to an exciting collaboration between Microsoft's learning initiatives and some of the things that are going on at NASA with respect to the Artemis project, which is going to take us back to the moon. And the larger goal here is to introduce you to some of the basic concepts of programming and get you interested in working with the Python programming language and some development tools that Microsoft provides, and prepare you to do some future work with data science and machine learning. So my name is Brian Sletton. Welcome. It's a pleasure to be with you today. I'm joining you from Northern California, where it's much earlier than it is there. So bear with me if I seem a little spacey. It's not just the topic; it's also very early. Um, so we're going to share with you a link that you can follow along with, and the expectation is that you can do things as we work through the sessions. We're only going to have time to go through the first couple of portions of this larger learning path, but hopefully you will feel comfortable to go through some of the final ones on your own once we've gotten you to the point of installation and getting everything up and running. So um, if you do run into any issues, please feel free to ask about them. It'll be difficult to try to resolve them during the session, but hopefully maybe afterwards you can reach out if there are any issues. Hopefully there won't be any problems though. And if you have a computer that's available with a good internet connection, obviously you're tuning into the stream, but we will have you install Microsoft Visual Code, the Python programming language if you need to, and some extensions in the Visual Code environment to help you follow along. If for whatever reason you get stuck and you just want to watch the stream and come back to it later, that's a great way to learn as well. So this is a fairly introductory session. So if you know a little bit already, be patient, and maybe we'll hit upon something that you haven't seen before. And then next week we'll be doing some deeper work with the data science aspect of this in machine learning in a follow-on session. So hopefully you can come back and join us for that as well. So the link that will be shared with you is to a learning path that is called Discover the Role of Python in Space Exploration. And we're going to spend a little bit of time just talking about the space exploration part of it first, and then we'll get on to helping you install the software, and then some basic coding examples to get you comfortable with the idea. So if you click through the link, you should be taken to a document that looks like this. And so this is a structured walkthrough. It's a tutorial that you can follow along on your own. There's some other learning paths that are available to you too, if you're interested after the fact. But you'll see that there are a series of web pages with some information presented. There are links for you to explore. I'll highlight some of the ones that I thought were interesting. And then at the end of each section, there'll be a series of questions that you can answer to gauge your own process. And it's also fun because you can get rewards and little trophies and things associated with your learning activities to track the progress that you're making. So I hope you enjoy this. I hope you have fun, and let's go ahead and get started. So part of the idea here is that we are going to get you comfortable with the idea of programming. We'll talk a little bit about what a programming language is and what do these tools do for us, so that you can be more comfortable trying new things. And one of the things that will be possible for you to eventually do, depending on where you're coming from, is to play around with data. And one of the important parts of working with machine learning and data science systems is the ability to read the data in. So it's going to come from some place, maybe a database or a file, someplace on the web, maybe, through programs like the NASA space programs. They release a lot of data, and there's so much data that's being produced these days that we're going to need more and more and more people around the world who are comfortable working with it. And so it's a good opportunity to learn what's possible, and maybe it's a new career, maybe it's just something you do for fun, but we will lay the foundations for that for you. So we're going to talk a little bit about programming languages. We'll talk about the programming language Python in particular, and the Visual Code Studio and its plugins. So this is part of a larger initiative where, just to give us some fun, what are called domain topics, right, where you're talking about a particular field of study. You could be talking about finance, you could be talking about security systems, you could be talking about interesting customer data, but we're going to be talking about data with respect to the NASA Artemis program. And Artemis is going to be really exciting in about 4 years, where we are planning on sending the first woman and the next man back to the moon as part of a larger initiative to explore what does it mean for humans to be in space for longer trips, and ultimately as sort of a launching pad for moving on to Mars. Before we are able to go to Mars, we need to get more comfortable returning to space, spending time there, traveling around on the surface of planets that are not Earth. And so there's just a lot of research that has to happen first. And so the Artemis program is underway, and it'll be really fun to watch it unfold over the next couple of years. So the Artemis name is obviously a relationship to Apollo. Artemis is Apollo's sister. So notice here there's a link that at some point you can follow, but just to show you what's there, this will take you to NASA's website and tell you a little bit more about the program. There's some documents, pictures, images talking about the plans and the goals of the initiative. But beyond just the mechanics of putting humans back in space and landing on the moon, it's going to be an opportunity to explore new technologies, new ground systems, new launch systems. The Orion spacecraft is how the astronauts will land on the moon and then get back to Earth from there. So that's the orbiter. There will be communications that are set up. I've seen some things recently about how they're going to try to have 4G-like capabilities, and so we're going to have to figure out, like, how do we deal with latency, which is the time that it takes for a signal to get to where it's going and maybe get a response back. The speed of light is very fast, but it still takes time, right? So there's a delay in when communications can be responded. So a lot of the communication protocols that we use on Earth, because obviously the distances are much shorter between, say, Seattle and New York, or New York and London, but we're going to establish communication protocols that will be even more important and interesting once we get further out into Mars and further distances away. But beyond that, there's even what does it mean to be in a spacesuit for that long, and how can we make them more comfortable? And so there's some fun links here about the kinds of opportunities that NASA has in terms of design contests and whatnot with respect to the emerging suits. So keep in mind, this is the nature of the problem that we're trying to solve. Next week we'll be doing some more data science with respect to, for example, rock samples, right? And trying to do some reasoning about those. But today we're just going to get you comfortable with the idea and set up and do some basic programming. So I'm going to move on to the next section to talk about some of the goals here. It's been 50 years since humans were back on the planet, on the surface of the moon, collecting rocks and whatnot. And it's exciting that they were able to bring stuff back. We've had another big development this week where the Hayabusa orbiter that landed on the asteroid and collected some rocks returned to Earth, and the Japanese researchers have found the return unit and are now going to go off and analyze rocks from asteroids, which is very exciting. But obviously, these are very delicate. We have to be careful about exposure to heat and sunlight and physical trauma and moving. So the rocks themselves have come back and have been under lock and key at the Johnson Space Center. And if a researcher wants to work with them or take off a little sample, they can go do that. But obviously, there's only a small number of them, and they've been analyzed for several decades now. So it's exciting that we're going to get to go back and we're going to collect more samples and bigger samples and bring them back and provide a new supply. And that's important because the analysis that we can do against them will tell us about the chemical compositions of the materials on the moon, which will tell us something about how it evolved, the presence of comets and whatnot hitting the surface of the moon, not comets, meteorites hitting the surface of the moon, and how it formed and has become what it is today. So the idea of collecting these rock samples is going to be a big part of the Artemis project, and will form sort of the structural analysis of how we think about machine learning in the subsequent session. All right, moving on. In addition to that, there's a real opportunity to encourage people, particularly young people, to get involved in science and technology, engineering and mathematics kinds of initiatives. That's a big part of the effort to do things like space programs. It takes generational thinking because we've been talking about this for a while, but we need to think 4, 5, 10, 20 years out. And so children who are learning now will become the programmers and the engineers and the scientists and the researchers in that kind of time frame. And so there are a lot of great programs that NASA is sponsoring. And if you have children, it would be some great opportunities for them to explore, maybe some future opportunities in these fields. So, on this site here, we've got the STEM programs listed and the suitability. Some of them are for wider ranges from, say, K through kindergarten through 12th grade, or younger groups. But this is just, again, some background material and some things for you to explore. But the idea is that getting somebody to the moon and bringing them back safely is not something that a single group can do. It's not something that even a single organization or country can do. It takes the whole planet, because we have to have communication centers around the world because of lines of sights of communication. We've got to have shared researchers exploring with imagery that's coming back and telemetry information for the vehicles as they're moving around. And so it's a really a global effort, and NASA is just kind of spearheading the effort. And then it takes the partnerships with organizations like Microsoft to spur interest in programming and developing skills and preparing next generations to be involved. So it's a collaborative effort, and that's one of the most exciting things about it. Given all the bad and painful things that have happened this year with respect to the global pandemic, seeing collaborations there start to become successful with new vaccines being emerged and people working together in space exploration. That's to me, it's always been one of the most exciting things that's going on. So I'm not going to go through and read all this text here, but there's some interesting personal ideas about what it means to be inspired by space travel. One of my favorite authors, Antoine de Saint-Exupéry, who wrote The Little Prince, talked about how if you want people to help you in an initiative like building a boat and going to sea, you don't tell them what to do. You don't say, go cut that down that tree and saw it and sand it. You get them to dream about going to sea and exploring, and then their passion will drive them to work hard and help together. And that's a little bit what's going on here, is that, this idea of people with this larger vision of exploring the moon and getting to Mars and all the side effects that will produce that will come back and help humanity from medical, communication, technology kinds of perspectives is very exciting. So I encourage you to, again, as you're going through this, read through some of these thoughts with the various administrators and executives and lead researchers that are involved in the project. But the main idea is that it's a group effort, and we need to encourage people to get into programming systems. So there's crazy amounts of data that are being produced these days, and more data is being produced than hardware is getting faster. Usually computers get faster over time, and they're not getting as fast as they were in the past because of the physical limitations of chip manufacturing and some other low-level engineering details. So we have to rely on new types of hardware. You may have heard of things like GPUs, graphical programming units. These are useful for video games and 3D graphics, but they're also useful for science and numerics. And you may have heard of cloud computing. One of the things, in addition to the developer tools that Microsoft provides to the individuals, is what are called cloud services. And in particular, they have a platform called Azure that allows you to, if you need to spin up a lot of capabilities to analyze the data, it's like you can just magically start up a bunch of computers and then say, now go think about these things for a while and analyze the data. And then when you're done, you can, in essence, shut them all back down again. So it's not just about the tools. It's not just about the data. It's about the computational abilities that are available. And not everybody has access to that. Not everybody has computers lying around. So having the ability to spin up and load these capabilities in what we call the cloud, it's really just Microsoft's data centers have excess capacity, and they let that capacity be used or rented as time is needed by people solving specific problems. All right, so where we are, we've gone through the first part of this. We just want to make sure that you're able to follow along, that it makes sense. So I'm going to give you just a couple minutes to quickly look at this first step. And again, the idea is just to get you comfortable walking through the learning path process, answering some questions to sort of track what you've done along the way. And that will be useful once we start getting into more concrete learning activities with respect to the programming languages and whatnot. So this first step has a couple of questions. What is the goal of NASA-themed Microsoft Learn modules? When was the last time a human landed on the moon? And when will the next person land on the moon? So the idea here is just aware of the trends, aware of the initiative, being aware of the time frames. So I'm going to skip over just because I don't want to give the answers away. But while you're while you're working on that, I'm going to move on to the next step. Now, there's a couple ways that you can get there. Hopefully, you've answered the questions and got your achievement. You can log in and save the achievement if you want, or you can just proceed. Please also feel free as we go through these units. If you have particular feedback, you can leave ratings on the sessions as well. Yes, the site is accessible after the meetup, absolutely. So feel free to bookmark it and explore, because again, there's a bunch of other learning paths there as well. So, but they definitely want to make sure that this is fun and interesting and people are enjoying it. So please do provide feedback to the modules as you go. If for whatever reason you get lost, you can follow the breadcrumb links up here at the top and go back to discover the role. The leftmost, discover the role of Python in space exploration. So I went back there, and now I'm at the installing coding tools for Python development. So in this section, we're going to talk about programming languages and what they do for us and how we interact with them. We'll talk a little bit about Visual Studio Code and hopefully help you get it installed. Again, I apologize given the short time frame and the distance and everything. It'll be difficult for me in real time to debug any installation issues, but please do feel free to ask them. Possibly some of the other students will be able to answer them if they've seen something similar. That happened last week, and that was helpful. So, all right. So the good news is, we think of Microsoft as being mostly associated with the Windows operating system, but over the last several years, they've become very interested in supporting other operating systems as well. So you can install Visual Code on Windows, or you can install it on Mac OS, or many types of Linux systems. So depending on what kind of computer you have, you should be able to participate. And Python itself, obviously, of course, works on all these platforms as well. In fact, for Mac computers and Linux computers, it's installed by default. Now, which version of Python you have may be an issue. There have been two simultaneous versions for a while. One was 2 something, one is 3 something. We want to make sure that we're using the 3 something version, because the 2 something is basically considered unsupported at this point, and there are changes in how the programming languages work, and so we just want to make sure that there are no issues with that. So let's start on the second module. So the idea here is that a programming language is a way of expressing ideas, and you may hear people talk about programs or code or software. All of these things are names for the same thing. We have a question: is it possible to do the code in Jupyter Notebooks? Yes, we're going to be using Jupyter Notebooks momentarily. So I'm first just going to talk about Python and Visual Code, then we'll get those things installed, and then we'll make sure that you're able to get up and running with notebooks. And I'll explain what notebooks are for everyone else who doesn't know what they are. We'll get there in just a moment. All right, so all of those names, code, software, program, all mean roughly the same thing, but it's a way of letting humans and computers communicate. And back in the day, when NASA was first going to the moon, the kinds of programming languages that were available were much simpler and more directly the way the computer wants to think, not the way humans think, in terms of low-level instructions and memory addresses and things like that. But it's easier for us these days to use what are called higher-level languages. They're more comfortable for humans. They're not natural text. We're not just sort of using our English or French or German or Japanese kind of languages, but we're able to express ideas in a more simple and meaningful way. Makes it less annoying as a programmer. And then the runtime will interpret those languages in ways that the computer understands. And so it's translated into the lower level code for us. And so Python is the programming language that we're going to use because it's very easy to read, it's easy to write, it's got what's called a clean syntax, which is the way that you express the ideas. It's easy to understand what's going on compared to some of the more complicated low-level things that are out there. Now, part of the reason why it's important for it to be clear and easy to understand is because it's easy to get confused and it's easy to make mistakes, and those mistakes are going to translate into what we call bugs, right? The idea that there are bugs inside the computer and it's making it not work. So we want to debug the software by using tools to make sure that the logic makes sense, that what we're trying to say makes sense. And so we'll be using some of the tools in the Visual Code environment to help us with those debugging activities. Now, don't be embarrassed if there are bugs. When I interview people for programming positions, my favorite question to ask them is, what's the worst bug you've ever written? Because that tells me something about the hard problems that they've solved, or if they haven't solved any hard problems, then they won't have written any good bugs. And my worst bug involved removing the operating system of an IBM workstation that we didn't have the installation media for. So my boss had to pack this thing up and drive it to the customer site 2 hours away to reinstall it. But I learned some important lessons. And so anybody who writes programs, even people with 20 plus years of experience, will create bugs. That's not a problem. The problem is, how do you learn from them? How do you approach them, problem solving to get through them. So if something doesn't work or you do something wrong, don't get too stressed out about that. So we are going to use, as I said, Visual Studio Code, which is a new, we call it a cross-platform. It works across all these different operating systems. It is open source. The open source part of it means it's free, it's available for people to look at the code, so they can look at how it works if they want to, or they could just use it. Doesn't really matter. But it's also extensible. It has what are called plugins, and those plugins provide extra behavior. So Microsoft is providing the basic tool and the environment and the infrastructure, but then individuals can modify it and extend it. And so it's a very popular, widely used development tool across a wide number of projects and languages. And so in order for it to, the Visual Code itself understands lots of programming languages. So we're going to install the Python programming language and then configure it to work within Visual Code as the next step. So you can install other programming languages if you're interested in JavaScript or some of the other learning paths through the Reactor program. You'll be able to continue to use Visual Code, Visual Studio Code there as well. So Python is used in these examples because it's very popular, and it's also very popular in data science and machine learning activities. And there's a lot of reasons for that, but the main reason why we're focusing on it is because it is widely used for that purpose. It's an easy language to learn, and learning it is useful, and we need more people to understand it. The name is kind of funny. It's named after the Monty Python TV show. There's a typo here that says Money Python, but it's Monty Python. You may have heard of them, and it's kind of a tongue-in-cheek name, but it's been a very popular programming language since 1991, and the guy who created it was named Guido van Rossum, who retired recently and then came out of retirement recently because he got bored, I guess. And in any case, it's designed to be easy to read. So there's more structure to how you say things in it than maybe in other places. with respect to what's called white space. So tabs and spaces and things around the definitions in the program are potentially more meaningful in Python than they are elsewhere. And that bugs people a little bit initially because it's easy to like have an extra space or something, and that causes the interpreter to maybe act a little crazy. But the good news is once you get comfortable with it, what that ends up doing is it makes the code very readable. So it's worthwhile doing that. So I'm not going to go through the process of installing it just because I want to make sure that I have a working version and there are no network issues or anything. But I'm going to show you what you need to do to install it. So if you go to code.visualstudio.com/download, and we can make the link available here. And share that with you. Then you can pick which operating system that you want. So if you're on Windows, you can click this button. If you're on Linux, depending on whether you're using Ubuntu or something like Red Hat, you'll pick one of those. If you're on a Mac, you can pick this one. And you should see it end up downloading to your downloads directory, and that will take a little bit. So while that's going on, I'm going to move on, but please feel free to go ahead and start that process if you do not have it installed already. Once that finishes downloading, then you'll have to go through the installer process. And one of the things the installer will ask you to do is to read the license agreement. Just make sure that you understand, the limits and whatnot are Microsoft is accepting with respect to this open source software. It's fine, right? You should read it, but if you just skim through it right now and maybe come back to it later, you'll have to accept the agreement and then move on. So once it's downloaded, run the installation program from your downloads directory or through the browser. Usually you can get to the download, and then accept the license agreement after reading it, and then hit next. You'll want to make some choices. Most of these should be okay, right, with the defaults, but you may want to select the thing that says add to path. What that means is it will help your operating system find the tools by looking where they're installed. So if you reference Visual Code, it will be able to find it and execute it. So that's an option that you'll need to check, and then hit next. And at that point, it should be ready to go and available. So again, this may still take you a little bit of time. I want to give you some time to do so, to follow along. But do you know why I installed this specific content environment to get last week's this week? So I do not know that off the top of my head. We have a question about an issue from the previous version. Generally, it may mean that it can't communicate with the Jupyter Notebook service. Usually, closing code down and opening it back up helps. If that doesn't work, I'll show you a couple of other things that may, but we'll see if we can help you afterwards if that's not the case. So I already have this installed. So I'm going to run it. And again, while you're downloading and getting things up and running, you can follow along. On the Mac, it's located under Applications. On Windows, it'll probably be under the menus, or you should be able to type Visual Studio Code in the little search box, and it should find it. The icon that you want to look for looks like this, and if you run it, as the website shows you, you should see something like this. Now, obviously, yours may look a little bit different. I've got a lot of things installed. I've opened up a lot of projects. But in general, when you come up, it should look basically like this. There'll be like a little welcome tab here, and a series of icons here on the left. A menu up at the top. A lot of the menu items correspond with the icons and the elements and the things down here. So if you are following along, then the icons here correspond to the Explorer. So this first one that looks like a couple of documents shows you which files you have opened and the contents of a particular folder if you're in one. If you want to search for particular keywords, you can click on the search little magnifying glass there. Oftentimes when you're working with other people or even just yourself, you want to keep track of the changes that you make so that if you make a mistake or want to get back to an earlier version, you can do so. So usually use a change management system. You may have heard of like Git or SourceSafe back in the day, but these are change management systems. We don't have time to go into them, but those are useful. There's, I believe, some learning paths on working with those systems as well. Obviously, we want to run our programs, and so the tools around executing the code in the studio are available through this icon. We're going to install some extensions, and so the extensions are generally available through this set of blocks. And then for interacting with the Azure operating system, or sorry, excuse me, the cloud services or Docker containers, which are ways of packaging software. We don't have time to talk about those, but those are other integration points within Visual Code. So hopefully you're able to get it installed and up and running. If not, maybe you come back and look at this next step, which allows you to run Visual Studio Code in your browser. I'm not going to go through the steps here, but just to make you aware that there's this new thing called Code Spaces. You need to have an Azure account, but it's free. Just go to the portal here and register. And then you'll be able to run Visual Studio Code directly in your browser. So you won't have to have it installed locally. Now that does make a little difference in terms of how it accesses files and whatnot, but for the most part, it should be very comfortable and similar. So if you have any issues installing it, consider this optional. This one's called Run Visual Studio Code in your browser. That's an option for you as well. All right, so the next thing that you need to do is to make sure that you have the Python programming languages installed. And here is a link that we will give you, but it's just python.org/download. Oops. I want the link, not the text. And you want to make sure that you get the Python 3, whatever the version is it currently says. Make sure that you're picking the one for your operating system. So you'll have the choice of selecting Windows, Linux, Unix, or Mac OS here. And then it will download it, and you'll have to go through a similar installation process. There's an installer. There's probably a license to accept. But for example, on Windows, you'll click the Install Now, and it'll install it in your user home directory. And then again, you want to add Python to the path so that the Python commands can be found by your operating system. So in the end, you should see, setup successful or something like that. So I'm not going to walk through that because I already have it installed, but that will take you a couple minutes to do so. While you're doing that, I'm going to move on, but hopefully if you get behind a little bit, that's okay. The video will be available and you can come back and watch it after the fact as well. So at this point, you will have Visual Studio Code installed. You will have Python installed. And now we need to sort of connect the two together. So that's going to be used through what's... No, you should be fine. As long as you have it installed, a Python 3 installed, you should be fine. I'll show you how to configure it in just a second if there's an issue. All right, so in order for Visual Code to have all the capabilities around Python, it needs to understand the Python commands, syntax, runtime, like how to communicate with your tools. And so we're going to install the extension. So if you click this icon here where we have like the little blocks that will take you to the extension page. And I'll do that. I'm not going to install it because I already have it installed. But if you type the word Python in the search box at the top, you should see it here. You want to make sure that you're getting the one from Microsoft, and you should just be able to install it. Once it's installed, you'll see a little green label or something like that. So that's the first thing that you want to do, and just click the installation button. It should take no time at all. It's a fairly small installation because it's not the language itself. It's just tools for making code work with the language. Once you have the Python extension installed, then there's another one called Intellicode, and that is useful for interactive analysis. Like as you're typing, it will maybe make some suggestions for code completion, so you don't have to remember everything. It helps you remember the names of some of the commands and the code samples and everything. So the Intellicode extension is the next thing. So just search for the word Intellicode, Visual Studio Intellicode. It'll say AI assisted development from Microsoft. Hit the install button, and that will take a moment or two, and then you should have that installed. So let's just double check. Oops, Intellicode. I've got that installed now as well. All right, so the final step is that we're going to create what's called a Jupyter Notebook. And Jupyter Notebooks are really just a nice way of doing data science and machine learning, because usually you want to explain what's going on. And so there's a little bit of text and a little bit of code, and a little bit of text and a little bit of code. Normally, programming languages are just code with maybe some comments or something in it. But it's not easy for non-programmers to read the comments and to really understand what's going on. So packaging it up into a document that makes it easy for other people to work with is useful as well. So Jupyter comes from an organization that has multiple programming languages that are available. Normally, it starts up a background server and executes the code in the server. But the nice thing about Visual Studio Code is it packages that all up for you, so you don't have to worry about that. This works if you use Linux, but not in Windows 10. It should work, obviously, in Windows from Microsoft. There may be some command line issues or something going on there. But as long as it's working, I hope you should be able to follow along. All right, so once you have everything installed, then we can close the extensions session and open up a folder. So you'll want to create a folder somewhere on your file system, usually in your home directory. I'm going to open up an existing folder. You can go up to File Open, or at some point you'll see, there's some options here. I can click on Open Folder, and it will show you, recent folders. I have one called NASA Python, and I'm going to open that up. Now I happen to have an empty Jupyter Notebook here. I'm going to go ahead and close it. But just to show you what that looks like, we want you to now create a new file. So you can say File, New File, and notice it opens up a tab here. You can hit Save. So depending on your operating system, it'll be like Apple Save or Control S to cause it to save. And notice it's going to ask for a name. So pick a meaningful name. But you also want to tell it that it's a Jupyter Notebook. So under the format, so actually, I'm sorry, I understand now what you're asking. We don't want you to use Anaconda for this one. We want you to use Visual Code. Some of these notebooks don't work in the Anaconda version, so that may be what's going on. I apologize, I misunderstood what you were asking earlier. Like I said, sorry, it's 4 o'clock in the morning. So if you can stick with Visual Code, it'll make it easier for the time being. There's no reason you can't use Anaconda externally, but just for this particular flow, that would be preferred. All right, so you're going to want to give it a meaningful name. So you can say, you know, exploration or something. Select the format. There's a bunch of different things that you can select, but down here there's one called Jupyter. So if you select that and save it, you won't see anything different right away, in part because it was just a regular text file. Now it's a specific type of file. So the easiest thing you can do is just to close the open tab and then open it up again. And at that point, it will recognize it as a Jupyter Notebook, and you'll see this other stuff. And so in this other stuff, you have some ability to execute commands. If you need to select which version of Python to use, you can click on this upper right-hand thing, and if it finds multiple versions of Python in your environment, you can select for those. I'm not going to change that. You can also get to that down here in the lower left-hand corner. Notice it says Python 3.9. So if you click that, it will pop up again to give you the ability to select that. So just make sure it's Python 3 something, which version you're using. You can use the Anaconda Python installation if that's what you're asking. Again, I'm trying to watch the chat while I'm going through this as well. Feel free to contact me at the end if you have issues. But in any case, we want to get you to this point where you can open up the notebook, file new, Control S, save, give it a name, give it a location, set it to a Jupyter type. But if you only see the empty screen and not some of these controls, then I would say hit the X and open it up again. And at that point, it'll interpret it as a Jupyter Notebook. So, all right, I'm going to move this over now just so you can focus on what's going on, but I encourage you to follow along the next step. So we've configured the Python notebook, and now we want to execute. Now you may be asked one final thing. If you get to this step and it says Jupyter cannot be started, you may see this little thing pop up and say, hey, you need to install that. Go ahead and install it. That's fine. I already have it installed, so it's not asking me that. But if you hit install, then you'll be able to execute the code samples. All right, so the first thing is that we have what's called an individual cell here. So we've got the larger controls up here. An individual cell allows us to execute a little bit of code. So if you're following along, if you say 2 + 2 and you hit the little green play button, that runs the cell, and notice it gives us the answer 4. And then it automatically creates a new cell. So we could say 2 × 3, hit enter, and that's obviously 6. You can delete cells by hitting the trash can over here to the right. You can add a new cell by hitting the plus button. So cells are really just a collection of little code snippets, and it makes it easy to sort of focus on what's going on. All right. Now, this is what's called an expression in a programming language, and an expression has a value. And so that's why when we hit the play button, we add it together, it executes the code, the value that returns is 4, and that's the return value here. We can also say, hello world. It's a very common first program. And hit the play button, and notice that now the value that's returned is the string hello world. So there are numbers and there are strings and other types of data types, but these are some of the primitives in Python. By primitives, I just mean the simple types that are available to you from the language itself. So hopefully you can enter a couple of strings. Notice the strings have quotation marks on them. They can be either double quotation marks or single quotation marks, and then the result will be printed out down below. Now, obviously, that's not all that helpful yet, but we're just at the basic installation process. So the next step is to go through and do the knowledge check. So we have how to humans communicate with computers. When software is open source, it means one of these things. And Visual Studio Code is all of the following except. So please follow along and answer the questions. I'm not going to give you the answers so you can test yourself. I'm going to jump back up to the top and then enter the third section, which is writing basic Python in notebooks. Now, as we wrap up in a couple of minutes, we're going to finish up through this section, but there are a couple of more sections on the website that we encourage you to continue to go through. So this will help deepen your understanding of the Python programming language, working with Visual Code, and doing some basic math with respect to the moon rocks and types and things like that. So next week, there'll be a deeper dive into the machine learning aspect of this, but I am now going to go into Module 3, which is write basic Python in notebooks in Visual Studio Code. And so this one, we're going to learn some basics of the programming language, learn some new ways of interacting with Visual Studio Code, and use some of the existing functionality in the Python programming language. So at this point, you should have Visual Code installed, you should have Python installed, you should have the Python extension installed, you should be able to create files and save them as Jupyter Notebooks, and then you'll be able to proceed. Again, if you're a little bit behind for some reason, fine, just come back and watch the video a little bit later. That should help you get caught up. All right, so we're going to jump to the add comments to Python notebooks to add clarity to your code. I talked about how important it was for the developer of the code to be able to clearly understand what's going on so that he or she doesn't make mistakes if possible. But it's also very important when you're working with others that your code is easy to read, so they understand what you're doing as well. And one of the ways that you can do that are to use what are called comments. And a comment doesn't do anything. It's just a way of saying something that's going on. Now, obviously, a comment that says this is a comment is not all that useful. But if you were going to say, you know, the following should produce the value 4, and then you say 2 plus 2. When I execute this cell, the comment doesn't change the outcome at all, but it tells us a little bit about something about what's going on. It's if it helps clarify what the program is doing, that's useful to put in the code. It's also important to make sure that the comments are kept up to date, because if I turn around and say 2 plus 3, this is no longer going to be 4, but notice the comment still says that. And it doesn't change whether the function works or not, but keep in mind, if somebody comes along and reads this and what it says is not matched by what's in the code, then they're going to be very confused, and it's going to be harder to be successful in that case. So comments are a great way to tell people what you're doing and why you're doing it, and help make sure that the code is clear. Now, don't go overboard. It's often very common for beginning programmers to comment things like, 2 plus 3 equals 5, and then say 2 plus 3, and then say, this is a string, right? That's not an overly meaningful comment. You want to say something about what you're thinking, why you're doing things a certain way, but it's also useful for keeping track of what you need to do. Like if you come across something and say, oh, I want to remember, change this statement. Notice the to-do is picked up as something that you need to get back to, and Visual Studio Code remembers those. So you can jump back and say, okay, what were all the things that I need to remember to do? That's a useful reminder to do something. Notice that the last statement, the last line in the cell is the only thing that's returned. So even though I say 2 plus 3 up here, that is executed, but because I'm not using variables or anything like that yet, only the last line is, if it's an expression, is returned as a value. Occasionally, you'll want to do multiple lines of comments. So you could say, I'm going to paste this in just so I don't have to type it. That's a useful thing too as you're going through the exercises. They made it very nice to copy the contents of a cell. If you hit the copy button, then you could go back and just paste it in. So it keeps track of the comments, and the syntax highlighting tells us this is a function that will take in some text. Don't worry about what the code is actually doing yet. We haven't talked about that, but just as an example, you'll have some comments that talk about the thing that's coming. And in this case, we're introducing a new bit of reusable code called a function. It has a name. You use the name to invoke the function at some future point. This is where we're defining it, and it's useful to have a block of comments explaining what the function is doing. And functions can be in after the line as well. So if we copy that and paste this into a new cell, notice in this case we're using a variable. The variable has a name called rocket speed. Python is nice because it's called a dynamic programming language, meaning you can just assign a value to a variable, and whatever that variable is, whatever that value is, the type of that value becomes the type of the variable. Other programming languages make you tell it up front. Here's a number, and I'm going to give you a number. That way, if you try to give it a string, it can say, "Whoa, you lied to me. Why are you giving me a string when you said it was a number?" But Python is very flexible. So in this case, we're assigning a value to it. But notice the comment can exist afterwards, and that doesn't stop it from working. So if I said rocket speed and printed out the result, obviously it's 17,000. If I put the comment here, and let's give it another name because it already knows about rocket speed. Let's say rocket position or something. If I try to run this, I haven't defined it, and notice you get an error, right? So the comment, the comment character here makes the whole line a comment, and therefore it won't execute. But if you remove the comment, only the part after the comment character will be considered not actual code. And if I execute this, this will now be fine. So here's where I assign the value to it, the variable, and then I use the variable. A variable is just a location in memory that keeps track of stuff that you are using. And then good names for variables makes it easy to understand what's going on. Sometimes people will just say x equals, and that doesn't really tell us what x is, unless you're talking specifically about geometry or plotting out something on a graph. We want to make sure that our variables have more meaningful names. All right, so we're going to look at a couple of more quick things, and then we'll wrap up. So Python as a programming language obviously is able to do math. So you should be able to type in 3 + 6 and see the answer 9. So if you had 3 rocks and you want to add 6 more rocks, you have now 9 rocks. So that should be the result. If you have 15 units of oxygen and somebody uses 3 units of oxygen, then in this case, we'll see the answer 12. So notice the comment tells us what the numbers mean. They don't change the actual execution of the code. So let's just go ahead and copy that, paste it in, and we see, happily, math still works. You can get more complicated. Try doing some multiplication. So if the rocket has a certain speed and it goes for 2 units of time, so if this is 17,000 miles per hour and it goes for 2 hours, then the answer would be 34,000. So try that. Try doing division, and notice this does something interesting. This is called an integer, which is just the integral, a greater than 0 portion of of the number. 4 is also an integer. But when you divide 100 by 4, it produces what's called a floating point number. And that just means that there could possibly be something after the decimal point. So if I copy this, paste this in, we see that it's 25, but if I divide by something that isn't cleanly divided into 100, you'll see that we have the trailing remainder part there as well. It's 0.33333. Now, for numerical scientific things, obviously we want to use these floating point numbers because oftentimes units of measure are not exact. But other times, if you're counting things, integers are just fine because, here's 1 glass of water. I could have 2 glasses of water, but I can't really have 2.3 glasses of water. So again, you pick a type for a value that makes sense to whatever it is you're doing. Integers are types, floating point numbers are types, and strings are types that we've talked about so far. We can obviously get more complicated in our math. So here we have what's called, or we're worried about the order of expression. And if you read this one way, you could say 2 plus 5 is 7 times 3 is 21. If you read it another way, you could say 2 plus 5 times 3, well, that's 15, plus 2 is 17. So it's important for a computer to understand what's going on. And generally, there's an order of precedence. In this case, the multiplication should happen first. So this should do the 5 times 3 first. 15 plus 2 is 17, and that's the result. If you want to do the 2 plus 5 first, one way you can do that is to put it in parentheses. So that tells Python, do this part first, and then multiply the result times 3. So obviously, in this case, the answer is 21. And that's the kind of thing where it's very easy to get this wrong. Like you meet it to do one thing, Python interprets it another way. Boom, you've got yourself a bug. And so it's nice to have the cells in Jupyter Notebook as a small number of lines usually. We're not talking about hundreds or thousands of lines of code. So it's easier to see what's going on. But be aware that these are called the orders of precedence. In general, multiplication and division take precedence over addition and subtraction. So let's try one more example. Let's say 7 minus 2 times 3. That's 2 times 3 is going to happen first. That's going to be 6. 7 minus 6 should be 1. And we see that it's working. But if you put the parentheses around the 7 minus 2, that becomes 5 times 3 is 15. So that's an easy way to make bugs. Not that you're trying to, but just be aware of that. All right, the final couple examples here then. There's some additional what are called operators, plus, minus, multiplications, division. Those are all what are called operators. This one's called the Modular Operator, and it deals with remainders. So 10 mod 3 gives us 1. And you may say, why is that 1? Well, 10 divided by 3 is 9, and then there's a remainder of 1. So sometimes modular arithmetic is useful to know if there is a remainder for something. You can raise things to powers. So if we want to represent the number 10 to the power 5.37, the 2 asterisks here represent to the power of. So 2 to the power 2 is 4, but 10 to the power of 5.37 is obviously a much bigger number. Now, if you want to do the old Python used to use a different type of division, where if you want to ignore the remainder part, you can. That used to just be regular slash in Python 2. In Python 3, regular slash does the floating point arithmetic. But if you say slash slash, that will say 5 divided by 2 is 2 with a remainder of 1, but the answer for 5 slash slash 2 is 2. Whereas 5 mod 2 would be 1. And then the final example that we're going to do here today is to introduce some variables. We talked about that already. We've talked about integers. We've talked about floating point numbers. We talked about strings. Another type is called a Boolean. It's whether something is true or false. So if you want to check whether something's been initialized, you may set a variable called initialized equals true. And then you could say later, if we have been initialized, then do this, otherwise do something else, like complain about that situation. Now, variable names should be meaningful. They should tell you what the variables are for. That makes it easier to read the programs. But they also have to be defined, as you saw. So if I copy this and run this example, I can set up these variables. And now I can refer to them. So notice Visual Code keeps track of things that you've seen. So I typed NUMER, and it's like, whoa, I don't know what that is, but I see something similar. You can select that, and it's just a useful reminder. So that's the Intellicode making your life easier. And notice if I hover over it, it tells me that the answer is 5, and it knows that because it set it up there. If I say number of books, we don't have that defined yet. So if you hover over it, it doesn't tell you anything. So again, this is how the tool makes your life easier as a programmer, by giving you hints as to what's going on. So number of rocks, if I print that out, is 5. Is the rocket turned on? The answer is no. I could change that. I could say rocket on equals true. And then if I say, is the rocket on? It is now true. So Boolean variables deal with true and false. Strings deal with the names of things. Floating point numbers deal with numbers that have a portion after the decimal point, and integers are numbers that do not have anything after the decimal point. Now we're out of time, so I'm going to let you finish this out yourself. But you'll see that there are ways of adding things. So if you set the value basalt rock count is 0, and then you add 1 to it, or set its value to 3 and add 1 to it, then these 3 instructions will all be executed, and the answer will be 4. But what's interesting is you can say plus equals as a way of saying, take the value that's there, and then add this value to it, and then assign it back to itself. So in this case, I do this in a couple of steps. Basalt equals 3, basalt equals basalt plus 1, and then print out the value 4. I could just say basalt plus equals 1, and that's just a more compact way of saying the same thing. Oftentimes with programming languages, there are different ways of doing the same thing. Different programmers will have different styles. So there's just a couple of final examples, numerically and working with text. Strings have additional capabilities on them, like the ability to turn them to uppercase or to lowercase. So these are functions on the string itself. So if you say, here's the variable and it's a string, then Python knows it's a string once you assign it. Then you could say to upper, or upper will generate the uppercase version of the string and assign it to, in this case, the variable. So now if the name was Ramey Morris, now it's capital Ramey Morris, like you're yelling on the internet. Occasionally, you'll get a string that's in a weird state. If you want to put it into a known state where the first letter is capitalized and everything is lowercase, you can use the capitalize function on the string. Python allows you to connect 2 strings together. So one string plus another string is a bigger string, which is different than one number plus another number, which is a different number. So again, that's why it's important for Python to know what type something is. It decides how to respond accordingly. So I'm sorry that we're out of time, but hopefully you were able to get things installed, set up. You can execute these things out. You'll learn about lists. Lists are a collection of data types. In this case, a list can have multiple types in them. We can add in types of rocks. You can pull things off the front or the end of a rock, and that will modify the list. You can index into the list to pull out specific values. So in this case, we're defining 4, we remove 1, then there's only 3. Then through the variable using the index operator, you can pull out the first element, or the one in the 1 position. Keep in mind with programming languages like this, we start counting at 0. So in this case, basalt is in the 0 position, highland is in the 1 position, breccia is in the 2 position. So even though it's the third one, we would refer to that as position 2. So these are the kinds of things that you should feel comfortable playing around with. If you refer to something outside of the range of the list, like rock types 10, it will give you an error and it'll say, hey, there is no 10, but that's okay, right? It's not a problem. You're not going to break anything. It's just a way for you to experiment. And then you could assign values to list positions as well. So in the end, we will have learned about variables. We have learned about types. We will have learned about lists. We will have learned about strings and adding strings together and doing certain kinds of math. And this is the basics of just getting comfortable with Python. There's a print function that you can pass in a value. I skipped over. I apologize about that. But that's a way of telling Python to show something along the way. So if I go back here and I say rocket on, print rocket on, and then rocket off, or sorry, rocket on equals false, print rocket on. This should print true, and then it should print false. So at this point, rocket on is true from when I said it before. This prints out the value. I set it to false, it prints it out again. The variable is now false. All right, so go through, check your answers, and then we've now covered the first 3 sections. I encourage you to go through the next 2. You'll learn about control codes, controlling the flow of logic in the next one, and then some additional steps for counting the number of moon rocks by type. These final 2 are good ways for you to continue to explore and play and learn. But I hope this has been helpful, just to kind of get you started, get you comfortable, get the tools installed, hopefully give you a sense of what it looks like for them to be functioning, get the extensions in, to see what a tool like Visual Code does for you, Visual Studio Code does for you. It really helps you out. It's like a little friend sitting on your shoulder saying, oh, hey, you can't do that, or this is what that currently is set to, or is this what you meant? And that will help you be more successful, productive, and hopefully have fewer bugs. You know, you shouldn't feel bad about having bugs, but we don't want them if we can avoid them in our code. So then you can save the notebook out. You can close Visual Code down, open it up again, and get back to your notebook, and it'll also be there, and you should be able to continue to work. So please do fill out the survey. You should get a link in the chat for that. Please do rate the modules as you're going through. Create an account, log in, get your achievements for making it through them, and then please go on and explore the next couple of modules. The video will be available. If you missed something or want to go back and review something, feel free to jump to that. But otherwise, I hope we have given you the skills to just get started. And then next week, we'll dive into some more machine learning kinds of tools around it, just so you can get comfortable with what that looks like. All right. Well, thank you very much, and I hope you are doing well and stay safe and enjoy learning about doing Python, and in particular, using it to explore some ideas around the domain of NASA's trip back to the moon. It's an exciting thing, and just gives us some interesting examples to play with. All right. Thank you very much.